Hello everyone, I am Mrs. Priyanka S, Assistant Professor, Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today we are going to see about the root locus example. These are the learning outcomes. At the end of this session, student will be able to solve root locus example, do the stability analysis for the given system. These are the contents: introduction, root locus example, and the conclusion. Now take a pause and remind that root locus rules. In the previous section, we have studied about the root locus rule. So when we have the root locus rules, then we are going to solve the root locus example. So in these rules, we are going to calculate how many number of poles are there, how many number of zeros are there, what is the breakaway point, centroid point, asymptotes and their angles. And with the help of these rules, we can calculate the root locus example and we can analyze the stability. So this is the problem statement for unity feedback system. So here G of S, H of S is equal to K upon S into S plus 2, S plus 4. So here we have to draw the root locus and comment on its stability. So here there are the 3 poles and zeros are 0. Now step 1. In the step 1, we have to identify the poles and zeros. So already we have seen that there are the 3 poles, 0, minus 2 and minus 4. So here we are going to plot here 0, minus 2 and minus 4. So no zeros are there. Now as here number of poles are greater than number of zeros, so number of branches is equal to number of poles, which is equal to 3. Now for calculating this, for the breakaway point, we should have where the root locus is lying or not. So here we have a 3 region, 0 to minus 2, minus 2 to minus 4 and minus 4 onwards. So in between 0 to minus 2, if we consider this region, to the right side of this region, only one pole is there and 0 is 0. So addition is what? Odd. So root locus will be lying in between 0 and minus 2. Then next, in between minus 2 and minus 4. So if we consider right side of this point, so there are the 2 poles and 0 is 0. So addition is what? 2. So addition is even, so no root locus will be there. Now from minus 4 onwards, here if we consider this region, so to the right side of this region, we have a 3 poles, 1, 2, 3. And 0 is 0. So its poles plus 0 addition is what? 3. That is odd. So here root locus will be lying. So this root locus we are going to calculate for the breakaway point. So one breakaway point will exist here or here also. So this is about plotting of the poles and zeros. In the step 2, symmetry and endpoints. Root locus is symmetrical about the real axis, and it will start at open loop poles. So 0, minus 2 and minus 4. In our example, there is a no 0. So actually it will end at a 0 and starts with the open loop pole. So here no zeros are present. So at infinity it will be end. The step number 3, that is number of asymptotes. So here if that branches are there, 3 branches are there, we have to plot that branches, and that branches are called as the asymptotes. And for calculating the asymptotes or for plotting the asymptotes, we should know that the angle. So here number of asymptotes is equal to number of branches. 3 minus 0 is equal to 3. And angle we are going to calculate with the help of this formula. Theta is equal to 2q plus 1, 180 degree upon p minus z. So for different values of the q, 0, 1, 2, we have calculated 3 angles, 60 degree, 180 degree and 300 degree. So we can plot this asymptotes with 3 angles. Then step number 4, that is the centroid. So from which point we have to draw the asymptotes. For that we should have one point, that point is called as a centroid, and which is calculated with the help of this formula, summation of poles minus summation of zeros divided by p minus z. So here centroid will be minus 2. So what we have to do, here we have plot this minus 2 point, that is the centroid, and from this minus 2 we have a 3 branches, okay, that 3 asymptotes with the angles 60 degree, 180 degree and 300 degree, theta 1, theta 2 and theta 3. After that, step number 5, that is the breakaway point, we have to calculate it. So for calculation of the breakaway point, we should know that the characteristics equation, the 1 plus g of s into h of s equal to 0. So in our example, our g of s value is k upon s into s plus 2, s plus 4. Okay, so we have put here value h of s is equal to 1. So when we do the cross multiplication, we have an equation s cube plus 6h square plus 8s plus k equal to 0. So k will be on left hand side and we have an equation k is equal to minus s cube minus 6s square minus 8s. So for calculating the breakaway point, we have to differentiate this k with respect to the s. So dk by ds is equal to 0, means differentiation we have to equate to 0. So when we have a derivative of this above equation, we have a 3s square plus 12s plus 8 equal to 0. Now next step is what? We have to take the root of this above equation. With the help of this formula you can calculate minus b plus minus under root of b square minus 4ac upon twice a. So after calculating, we have two roots, s is equal to minus 3.15 minus 0.846. So here we got two roots and we have to find out the breakaway point on the real axis, whether it will be lying on this s is equal to minus 3.15 or minus 0.846. Now we know that as there is a no root locus between the minus 2 to 4, okay, so root locus should be exist for the breakaway point. So therefore minus 3.15 it lies between minus 2 to minus 4 and there is a no root locus between this minus 2 and minus 4. Now what we have to do, we have to calculate the k value for both the roots, s is equal to minus 3.15 and s is equal to minus 0.846. So first we will put s is equal to minus 3.15 in this equation, then we will have the k value after calculation minus 3.085. So here we have to check whether the k value is positive or negative. So here k value is negative, so s is equal to minus 3.15 is invalid breakaway point. It is not a valid breakaway point. Now second, that is put s is equal to minus 0.846 in above equation, in this equation, and then we will have a k is equal to 1.87. So here k value is positive, so s is equal to minus 0.846 is valid breakaway point. So it will be lying in between that 0 to minus 2. Now step number 6, in this we are going to calculate the intersection with the imaginary axis, because from the breakaway point we are going to draw the root locus, okay, and that root locus will intersect with the imaginary axis, and at which point it will be intersect, that will be calculated with this procedure. Now for that we have to consider that previous characteristics equation, s cube plus 6s square plus 8s plus k equal to 0. So here we have to form a Routh's array. So for forming a Routh's array, we have to take the coefficients from this equation and we have formed the Routh's array that we have already discussed in the previous section. Okay. Now here this b1 value, that is 48 minus k upon 6. So here k marginal, when we solve this, we will get k marginal is equal to 48. 48 minus k upon 6 is equal to 0. Then we will get k is equal to 48. So here we have to take the above row, that is 6s square plus k equal to 0, because here when we put a k marginal is equal to 48, then above value will be 0. So here we will get 6s square plus k equal to 0. So here k marginal will be 48 in the above equation. Okay, so here we put the k value 48 and we will have s2 is equal to minus 2 which is equal to plus minus j root of 2. So after calculation, when we put the k value in the equation, auxiliary equation, we will have plus minus j 2.82. So root locus intersects imaginary axis with the point s is equal to plus minus j 2.828. Now step number 7, that is angle criteria. Here in our transfer function there is a no complex poles and 0, so there is a no need of calculation of angle of departure and angle of arrival. This is our final root locus plot. See here, you can first we have plotted the poles. Okay, if zeros are there we can plot that 0. Then in between 0 and minus 2 we have a one breakaway point, because here root locus line. From this root locus, from this breakaway point we have drawn the root locus. Okay, now this root locus intersect with this imaginary axis at plus j 2.82 and here minus j 2.82. And here already we have seen that centroid is plotted, and to this centroid we have plotted 3 asymptotes with the angle given. Okay, so here we have written that breakaway point will be s is equal to minus 0.84 and k is equal to plus 3.079. So finally we have plotted the root locus. Now for the stability analysis, step number 9. Here if k is less than 48 and is greater than 0, all roots are in left of S plane, hence system is absolutely stable. And when we put the k marginal is equal to 48, a pair of dominant roots on imaginary axis with the remaining roots in the left half plane. So system is marginally stable, oscillating at a 2.82 radian per second. So from the imaginary axis point, intersection point, we have calculated the omega value, which is 2.82. And when the k value is greater than 48 and less than infinity, dominant roots are located in right half of the S plane. So system will be unstable. So here we have calculated the stability analysis of that transfer function, given function. Conclusion: root locus starts at the poles and it will be aimed at the 0, and asymptotes and centroid guide pole movement. Here breakaway points and angle criteria refine the plot, and it will provide the stability and performance insights.